What are you? You? No, that's not possible. Is it not? There are certain things you can't do. And no, I'm not doubting your abilities. It's the laws of physics that come in the way. For instance, you can't create an exact copy of yourself. You can't send messages faster than light. You can't even tear the universe apart, rip off space-time. As much as we all might want to do that. This video is gonna be weird, actually absurd. We see the universe a particular way and I've always done so. Any changes to how it is would change everything. Asking why isn't things any other way, or why are there these certain things that are not possible, well, these might not be things that are compatible with our existence. Yeah, the good old anthropic argument, again, I accept that. But I believe there's still a place to discuss, at least once, to why. Why are there these impossibilities and what might breaking them do to our universe? This is, what if we did things that the laws of physics forbid? Well, the universe didn't like it. In the beginning, the idea behind the no wasn't just from the shock, but also from the fact that it is quantum mechanically impossible to create an exact copy of, well, anything. Though I'll agree that I was a tad bit too harsh there, you can always create crude, approximate copies that look almost identical at the macroscopic scale. I mean, that's what we've been doing for I don't know how long. But again, what defines an object? If it is the particular structure of its parts and the exact locations of all of the individual particles making it up and the exact quantum state for all of those particles, well, nah, that's not possible to copy. There's this thing called the no cloning theorem. Forget an entire object, even a single quantum entity as simple as a single photon can't be perfectly cloned. This is inherent to how quantum mechanics work, where any interaction done to a particle changes its quantum state and henceforth what defines its identity, something that is an inherently random phenomenon. What you can do though is teleportation. You can take a particle in a particular state and induce that same state into another particle far away. This act though inherently destroys the quantum state the original particle was originally in. So instead of a copy, what you get is sort of like teleportation. Even though what we've really done is to recreate the same state into a different particle, the effect does mimic what you would traditionally expect from teleportation. Quantum teleportation. Now the important or silly part. Why? Why does the universe forbid us from perfectly copying quantum systems? And by extension, anything? Well, there's something deeply unsettling about quantum cloning. Something that makes it quite apparent that there was really no way from the very start. To say this, start with two entangled particles and take them light years apart. Entangled particles affect each other instantaneously. Normally we can't send messages this way because the outcome of any particular measurement is completely random, and random data has no information. But cloning changes this. Particles have spin. For entangled pairs, measuring the spin of any one of the particles along any particular axis gives the other particle the opposite spin along that same axis with complete certainty. Let's say we can choose to measure the spin either vertically or horizontally. Which way we choose to measure the spin keeps the message that we're trying to transmit. So let's say measuring the spin vertically means I'm happy, while measuring the spin horizontally means I'm sad. I take one of those entangled particles and since I'm quite happy, I measure the spin vertically. What it does is that it forces the other particle at the other end to have the opposite spin along the vertical direction, while the spin along the horizontal direction remains completely random. This by itself is also of no use because the person measuring the spin at the other end to decipher my mental state does not know which way I measure the spin of the particle that I have until I tell them classically, which defeats the point. Measuring along any particular direction gives them some outcome, but with no way to tell if it came randomly or was bound to be that because of entanglement. But suppose you can clone your particles. This changes everything, because now you can do statistics. How? Well, at the other end, you can clone your particle to thousands with the same quantum state as the original entangled pair, the state which was affected by the measurement done by me. For half of them, you can measure the spin vertically, while for the other half, you can measure it horizontally. Now, here's the thing. Since I measure the spin of the particle at my end vertically, all the measurement done vertically at the other end would yield the same result. What are the odds of that happening by itself? Well, all the measurement done horizontally would yield a roughly 50-50 split, giving away the information that I measure the spin of my particle vertically and henceforth am quite happy, breaking the universe, something that would have let us send signals faster than light, giving way to receiving signals before they were sent, breaking causality. Though none of this actually happens because the universe doesn't let us perfectly clone a quantum system. Doing so inevitably destroys the original state in the original particle. And then you wonder, is it that the reason we can't clone a quantum system because it would have let us send signals faster than light, and that would have broken things up in the universe? On the surface, cloning and fast and light influence seem completely independent things, and yet letting one would cause the other. We can go one layer deeper. All of this happens because light is supposed to be this cosmic speed limit, which in turn is true because relativity demands the speed of light to be the same for all observers, giving rise to all of that space-time squishy business, making the speed of light the speed of causality. But again, why have any speed limit at all? And no, I'm not saying that the speed of light should be infinite. I mean, no, let light travel with its speed. But then, why should that be the same for all observers? What if it was possible to travel at any speed, even faster than the speed of light? What changes? One layer deeper, I guess. Light, in our best description of reality, is massless. Photons don't have mass. All of their energy comes from their kinetic part. So if we could travel to light speed, to us, from Newtonian relativity, light speed would be zero. In the absence of mass and motion, the particle, to us, wouldn't even exist. Why does the particle need to exist from all frames? Well, this might seem like a stupid question, but why not? I mean, I agree it would be a completely different world, but still, why not? To many, it would be completely obvious that a real entity must exist from all frames. This is logical, and I somewhat agree. But again, logic is built from experience, and if anything, why does the universe need to be logical in the first place? This idea that we talked about in reference to quantum cloning, well, this can be spotted in multiple places. Wormholes are technically solutions to Einstein's general theory of relativity, but to use them to do anything that defies intuition, defies reality, is almost always taken care of by the fact that it requires exotic, not yet known kind of stuff, something that has negative energy. There's technically nothing fundamentally that stops backward time travel, and yet it is hard to think of it working out. Quantum mechanics is weird and yet maintains a level of structure that holds everything together and not let things break down. Everything follows from the laws of physics, and yet you can't use them to predict anything because it's random and there's uncertainties everywhere. It's like everything is made to work out, if that makes sense. You can't even break the universe, tear space-time apart. The universe doesn't let you do that too. Suppose you want to cram so much energy into a small enough region that it blows space-time. If such a thing is possible, I only said that for dramatic purposes. More importantly, if you want to probe the finest structure of space-time, you can't really do that, because at some point the energies are enough to create a black hole, something that has this horizon that covers all of the mishaps that might have happened. Singularities. It's like a cosmic failsafe. Don't let anything happen that breaks the universe, or at least not let it be apparent. Though it could very much be that singularities are only part of a crude description of reality, and whatever is the ultimate theory gets rid of them. The fact remains that the universe doesn't let us probe the smallest of smallest length scales. There are reasons to believe that there is a smallest length. It's called the Planck length, roughly 10 to the minus 35 meters. So far, we've only been able to probe to 10 to the minus 20. The fact that there are ways the universe avoids encounters where we may see it break down is jarring. Almost like there's this sort of a limitation, like how a simulation might work. You don't have infinite speed, you don't have infinite resolution. Am I suggesting that the universe is a simulation? Well, technically I am considering what I just said, but no, I don't believe it on a day-to-day basis. Though it is a very good food for thought, something that really makes you think of why and what and how and wow. Amidst all of this chaos in the world, there's all these things that don't let the world break down. It's fascinating that everything worked out the way it did. I mean, just think of what if the universe was deterministic? That would completely change how people look at reality. Instead of there being a definite future, we are headed towards a potential future from a sea of infinite random possibilities. Does that make it any better? And no, I'm not saying that the universe is built for life. Nah, I don't think so. And yet, it's so cool that it is the way it is. If it was up to you, what impossibility among the many that the universe has forced upon us would you want to be possible? Even if that would mean that we wouldn't be here. Thanks for watching.